So we're going to get into graphing. In order to do graphing, there's a lot of information that you need to know. So I'm going to zoom in on this a little bit, and then I need you to pause it and copy it down, okay? But before you do, I want you to see that I color coordinated. That's the A, okay? There's the pink, the yellow, this is a little bit of both, and that's blue, okay? So you're going to pause that. Hopefully you have highlighters. If you don't, then I guess you don't. So I'm going to lower this a little bit so that you can copy it. Your job is to pause it right now, copy this down. And then again, I'm lifting up this, copy it down. And once you do that, I'm going to explain what this stuff means. So I'm assuming you've copied it all down. So what's going to happen is I want to show you, I'm going to exit this, see if I can do this right. So you've done the unit circle. So if you look here, here's the unit circle. I have it in radian mode, and it's a link in Schoology, and I have it in degree mode. It's the same exact point. See, 1/2, 3/2. If you look up here, 1/2, 3/2. And remember, the first number represents cosine. The second number represents sine. So the cosine of 60 is 1/2. So 60, 1/2. The cosine of 150 is -3/2. I mean negative rad 3 over 2. Cosine of 150 is negative rad 3 over 2. Now if I was to do sine, sine's the second one. The sine of 45 is rad 2 over 2. The sine of 210 is -1/2. So what I want you to see, and I have this video, and I put down the time, so I'm going to have to make sure I coordinate it here, is I want you to just watch this. I'm going to put it on fast, and I want you to see what happens when you instead,
and remembering that sine is all to do with the y coordinate.
There it is in the circle.
See how sine changes as theta changes.
Okay.
And so using this idea, or this definition of sine, we're now going to look at actually creating the sine curve.
So now they're graphing the sine curve from the circle, if you see how that relates to each other. Okay. And then I'm going to forward it to 153. And I want you to see, there it is fully graphed. Now if you look here, it's not in degree mode, it's in radian mode. So pi over 2 is 180 over 2, which is 90, 180. 270. So this is what the sine curve looks like. And then if we fast forward this to the time 325, let me see. If you look here, here's cosine. Oops, I didn't press play.
Think about context and our definition of cos in unit circle.
Okay, so you go all the way around, you graph those points.
See how the value of cos changes as theta changes. And now if we
to transfer that over,
cos starts out at 1, decreases down to 0, out to -1.
It's you graphing cosine.
And again, we have the same situation with the sine curve.
So I'm going to forward this to 410. And show you how it's graphed of cosine. Now if you look, they actually look really similar. But what I want you to see is the difference between the two. And by the way, that video link is there and the unit circle link, they're both in Schoology. If you look at the difference between the cosine, let me move this, and the sine, see how if you look at the y-axis, if this is the y-axis, sorry, that didn't go through, it's supposed to go through. This, for sine, goes through the point 0, 0. But for cosine, it goes through 0, 1. Okay? That means the cosine of 0 is 1. The sine of 0 is 0. Okay? So, the way that I remember it is if you look at the y-axis, see how it likes the letter C? So that's how I remember that's the cosine one. And then sine, if you look, that makes the letter S going through the y-axis. That's how I remember it, okay? So we're going to be graphing things, and remember they all are based on transformations, okay? So if you look, they're both waves, and they just start in different places. They look very similar, so if you moved the cosine over, it could be on top of the sine. But the first thing you're going to figure out is what they call the amplitude. It's the height. It's how tall it is. So if you look here, they want to know how tall is it, not from the top to the bottom. The amplitude represents how tall is it from the top to the middle, okay, which they call the midpoint. So there's a top, a middle, a bottom, a middle, a top, a middle, bottom, middle, top, middle, bottom, okay? The next thing there is there's something called the period. And the period, and you're going to have to be okay with all these little words, is, and I call it from one top to the other top. So it's, if you look here, the top of this peak to the top of this peak, which I had over here, is a distance of 360 degrees. That's called the period. But what that also means is the distance from here, the bottom of the peak, to the other bottom of the peak also needs to be 360 degrees. Which also means if this is going up the hill and that's the middle, here's going up the hill, the distance from here to here needs to be 360 degrees, or 2 pi. It will always be that unless there's a number in front of your theta or there's a number in front of your x. If it's x, it is in radian mode. So if you look down here, degree mode is theta, and radian mode means x. And you'll know that just based on looking at the equation, okay? The graphs would look the same, but the x-axes would be different. So instead of saying 60 degrees, I would say pi over 3 if it was in radian mode. If it was in degree mode, instead of saying pi, I would put 180. But the shape of the graph would be exactly the same, just like it was for the unit circle, okay? And we'll get into this more, so don't worry, it'll make sense, okay? Then there's something called the phase shift, and what that means is you're moving it. That's like the horizontal translation. Well, the horizontal translation, we've learned that before, right? It's not a straight shooter, but it's also affected by your period. So that means that if this is less than 360, it will get affected here. And we'll go over that, okay? The last one is your horizontal shift, your vertical shift. So you're moving up and down, and that's what's here. So it's very similar to what we've done before, but it's a bit more complex, okay? So with that being said, there's also something called a cycle, okay? A cycle is graphing it from one, like if I started here, this is top, middle, bottom, middle, top. That's considered one cycle because I started again. And then if I did top, middle, bottom, and then I did middle, top, that is another cycle. I have now graphed 2 cycles of the graph, okay? So what we're going to do is we're going to take this information and use it, and I'm going to actually take this packet apart to get pieces of information. So here is the parent graph. So let me write that. This is the parent. And you know it's the parent because there's nothing else happening. Now, we know it's going to be a wave. We also know since it's cosine, the first point will be there. We also know because it's x, it is in radian mode. Okay? If that same thing said cosine theta, then it would be in degree mode. And I'll do both so that you can see. The first thing I'm going to figure out is my amplitude. So my amplitude, which I made in purple, so this is going to be fun, is what's right in front. That means how tall is it from the top point to the middle point, okay? Because remember when we did that top, middle, bottom, middle, top, middle, bottom? So that's going to be, because there's an imaginary 1, it's going to be 1. So we know the cosine graph starts with 0, 1. So that means that's top. The next point would be middle, okay? So that means from the top, if I was to graph this, and we'll actually graph it, okay? The distance from the top to the middle is 1. The distance from the middle to the bottom is 1. So technically the total distance from the top to the bottom is 2. Okay, but that's not considered the amplitude. They measure the amplitude based on the top to the middle. Okay, the next thing we're going to figure out is the period. Well, the period is what is in front of theta or x. Well, there's nothing in front, so automatically it's 360 degrees, but it's not 360 because it's in radian mode, so that's 2 pi. Why is it 2 pi? Because pi represents 180 degrees. If you look, there's nothing being added, so there's no horizontal shift and there's no vertical shift. Okay? We'll get into graphing on the next page. Let's go to the next one, the amplitude. The amplitude is how tall it is. So just like we did before, the amplitude is 1. Okay? But this time when we look, what is in front of the x? It's a 2. So now my period is going to be, when it would normally be 360 over 2, there's that 2, but it's not in degree mode, it's in radian mode, so it's 2 pi over 2, which is pi. What does that mean? That means the distance, and I know it's funny words and you're going to be okay, from one hump to the next is pi, or 180 degrees. Where if you look here, the distance from one hump to the next is 360 or 2 pi. Which means that if this is shorter, so here it is. Let's say I had this, right? And that's 360. That means that now, I didn't do a very good job, but it's going to be half the distance. So remember, when it's with the x, it's not a straight shooter. So 2 really means 1/2. It is half the distance. Okay? We'll get into it more. Don't worry. Amplitude. Okay? What's the amplitude? 1. That means the top to the middle is 1. The middle to the bottom is 1. Distance vertically, distance vertically. All right. Now let's look here. X over 4 is the same thing as 1/4 x. So if you look, my k, my period represents 1/4. So that means k, which I'm doing in pink, is equal to 360 divided by 1/4. Well, when you divide by 1/4, you're really multiplying by the reciprocal. So you're really multiplying by 4, which is 1440. But we're not in degree mode, we're in radian mode. So I'm going to go 2 pi over 1/4. If I'm dividing by 1/4, I'm really multiplying by 4, which is 8 pi. 8 pi and 1440 are equivalent. Remember, if it's with the x, it's not a straight shooter. So 1/4 really means it's going to be 1/4 as wide. So that means the distance, if I was going to graph this, it's not pretty, I know. The distance from one hump to the next is 8 pi, or 1440. It is horizontally wider, okay? And this will make more sense when we get to it, okay? Let's do the next one, amplitude. This time, the amplitude, which of course I'm doing in purple, is 2. So that means now when I graph this, remember how the original one was at 1? Now it's going to be at 2, so it's twice as high. Now it's top, middle, bottom, middle, top. It's twice as high. But then what's true about the period? There's nothing there. So my k equals 2 pi or 360. Okay. Let's go to number 5, the amplitude. The amplitude is how tall it is from the top to the middle. Well, if normally this was 1, now it's going to be a 4th, which is here. So it's top, middle, bottom, middle, top. So it's shorter, isn't it? Because it's only a 4th. And then what's the period? 360. Or 2 pi because we're in radian mode. Okay. Let's go to number 6. We're going to get a little bit more complex. Amplitude. And as we're doing this, I want you to think about, would I have gotten that? So what is the amplitude? 3. What does that mean? That means if I was to graph this, if this represents 1, it is 3 times as high, top. But the middle's still the same, and the bottom's still the same. It's 3 times as tall as the original one, as the parent graph. Now I'm going to do the period. The period is the distance from hump to hump, or middle to middle, or bottom to bottom. But it's easiest for me to look hump to hump, because, I don't know, just for some reason the tops, it's easier for me to translate in my brain. But bottom to bottom should be equidistant. Middle to middle should be equidistant. Now, not middle to middle, because this is a middle going up, and that's a middle going down. They have to be both be going middle up, and then the distance has to be equal. Okay? Oops, I got lost here. Darn it, sorry. Okay, so now the period is 2 pi over 2, which is just pi, or 360 over 2, which is 180. Now, I don't know about you, but I actually do better in degree mode, so I like to show you degree mode, but I want you to see that this is the answer in radian mode. That means that not only, if this was the original, let's say top, middle, bottom, it's now 3 times as high, which I'm not going to do a good job with, and it's skinnier because it's half the distance from hump to hump. So instead of being 360 from top to top, it's now going to be 180 from top to top. Okay? I'm going to stop there and we'll do the rest in a second.